Okay, picture this. A spacecraft, right? Nearly 15 years out there exploring, and its mission ends. Well, not quietly.
Not at all.
It ends with this deliberate fiery dive straight into a gas giant's atmosphere. Just incredible.
It really is.
So today we're doing a deep dive into that, the Cassini space probe, its amazing journey, and especially that dramatic end.
And the legacy, right, what it left behind is just staggering.
Exactly. We'll look at those final images, some really strange stuff it saw across the solar system too, and, the data that still makes you wonder. We want to explore what it all means for you.
It's a perfect ending, in a way, for a mission that totally changed how we see Saturn and, well, everything around it.
Yeah.
Cassini gave us so much data, it's like a treasure chest. We're going to dig into some of the really cool bits.
All right, let's start with that grand finale, as they called it, this intentional, controlled flight into Saturn. It wasn't random. They did it on purpose, partly to make sure it wouldn't crash into moons like Enceladus, which might, have life.
A really responsible end, considering the possibilities. But yeah, the end of an era, definitely. And Saturn's atmosphere, just brutal.
Oh, yeah. The sources we looked at say it was probably, shredded into millions of bits by winds going thousands of miles per hour.
It just shows you the sheer power of these planets.
Yeah.
But even as it was breaking up, it kept sending data.
Right up until the signal died, and it sent back one last picture.
That final image, yeah. Taken from about, 300,000 miles out from the cloud tops. Pretty amazing resilience.
And there are two versions, which is interesting. One's black and white, apparently has better detail, our sources say. And then there's a two-color one that looks kind of yellowish. But either way, it's this incredible view of Saturn's storms.
Those huge swirling clouds.
And the scale is just mind-blowing. Some of those storms are as big as Earth. Really puts things in perspective, doesn't it?
It absolutely does. And what's fascinating is the speculation that popped up around this final part of the mission.
Oh.
Even though we got that last image from pretty far out, people were hoping for something closer, maybe even pictures from inside Saturn.
Which raises questions, right? Like how science news gets out. Did NASA hold back images from closer in, or even from inside the atmosphere?
Well, the reality of these missions is data takes time to process, to verify. And Cassini was long gone, destroyed, before it could have sent anything back from deep inside. The signal cut out.
But that didn't stop the speculation. And this is where our sources get really interesting. There's this idea, totally unconfirmed, of course, but it's out there, that maybe Saturn has a solid landmass deep inside.
Right, the idea that the clouds and rings are just camouflage or some kind of side effect.
Exactly. I mean, if there was solid ground in Saturn's core, how would that even work? It changes everything we think we know about gas giants, doesn't it? They're supposed to be, gas, no solid surface.
It's theoretically very intriguing, but yeah, it clashes pretty hard with our current understanding of planetary physics.
The pressure, the heat.
Exactly. The conditions inside a gas giant like Saturn are just immense. We think matter down there is in this weird, supercritical fluid state, maybe turning into metallic hydrogen deeper down.
So not exactly beaches and mountains.
Not in the way we usually think of a solid surface, no. It would need completely different ideas about how planets form, or maybe states of matter we haven't figured out yet.
So highly speculative.
Very. It really highlights that point, though. Science is changing all the time, but we have to look at new ideas critically. Our understanding gets refined, sometimes overturned, based on evidence.
Good point. Okay, so beyond the fiery end, Cassini was out there for almost 15 years.
A marathon mission.
And it didn't just look at Saturn. It apparently took pictures of virtually every other body in the solar system, which is amazing.
An incredible photographic record.
But here's a question that comes up a lot, especially since these missions cost so much. Why are so many of the Cassini photos black and white?
Yeah, that's a common one. And there's a solid technical reason for it. Cassini's main camera, its default mode, records images in black and white. It's fundamentally measuring the amount of light hitting the sensor, the intensity, across different wavelengths.
Ah, so it's not inherently seeing color like our eyes do?
Precisely. To get a color picture, they had to put filters in front of the sensor, usually red, green, and blue filters.
So, like taking 3 separate pictures?
Basically, yes. You take 3 different black and white shots, each one capturing just the light from one color range. Then, back on Earth, scientists combine those images digitally.
Wow.
They process them to create a single full-color composite image.
Okay, so that explains why the source material says creating color images is a very complex task. Much more work, more computer time.
Definitely more labor intensive.
Yeah.
You're essentially building the color from multiple monochrome layers.
So was it always just about saving time and effort, or were there times when black and white was actually better for the science? Because Cassini did send back some absolutely stunning color photos, too.
Oh, absolutely. It captured beautiful color images. But yes, sometimes black and white or specific filtered images were scientifically more valuable.
How so?
Well, for certain things, like analyzing fine details or structure, a high-resolution black and white image can sometimes be better. And using specific filters lets scientists study, say, the composition of the atmosphere or features on a moon's surface based on how they reflect very specific wavelengths of light.
I see. So it's a trade-off. Sometimes color tells the story, sometimes the black and white data or filtered data is key.
Exactly. It depends on the scientific goal for that particular observation. And speaking of amazing images, Cassini didn't just give us Saturn.
Right.
Some of its most puzzling and intriguing shots came from elsewhere. It captured some really bizarre stuff.
Okay, this part really caught my eye. The sources mention things that people have called, UFO sightings, strange objects.
Hmm.
Specific examples were things shaped like cigars, or just weird things on the surfaces of moons and planets, apparently seen around Jupiter's or Saturn's moons.
Yeah, those images definitely sparked a lot of discussion.
So when Cassini sends back a picture of, like, a cigar-shaped object near a moon, how does the science community handle that? You don't want to just dismiss it, but how do you verify what it is?
That's the critical part. Terms like UFO sightings are catchy, but scientists approach these anomalies very cautiously, very methodically.
Right.
Often, these strange objects have mundane explanations. They might be tricks of the light, like lens flares, or maybe reflections off the spacecraft itself.
Or glitches.
Or instrument artifacts, yeah. Maybe a cosmic ray zapped the sensor at just the wrong moment, creating a weird streak. Or sometimes it's just a piece of space debris catching the sunlight weirdly.
So how do they check?
Well, the great thing about the Cassini data is its richness. Scientists can go back and look at everything surrounding that image. What angle was the sun? How was the probe oriented? Which filters were used? Was the object seen in multiple images or just one?
Trying to rule out the simple stuff first.
Exactly. It helps differentiate between something truly unknown and something explainable, even if it looks weird at first glance. The sources mentioned a compilation clip, right? An animation showing lots of these odd images.
Yeah.
It shows there were quite a few unexplained moments captured over the years. Things that definitely need careful investigation and make you wonder. They invite you, the listener, to think about the possibilities.
They certainly do. I mean, Cassini just gave us so much. From the detailed science, that planned ending, to these genuinely mysterious, maybe even UFO sightings, it was an incredible mission revealing our solar system, but also how we even look at it.
And that data, that massive archive, is still being studied today. People are still finding new things hidden in it.
So what's the takeaway for you listening?
I think Cassini's story reminds us that even after decades of exploring, billions spent, the universe is just full of surprises. Always. And it leaves us with this final thought, maybe a provocative one. What other secrets are still buried in those huge data sets from Cassini or other missions, just waiting for, fresh eyes or a new theory to bring them to light?
That's a great question. How do we balance what we know, the scientific certainty, with these sort of tantalizing possibilities that are still out there in the great unknown?
Exactly. It's the ongoing adventure of science.